Hello friends, I welcome you in lecture number 17 on complex functions. In this lecture we are going to discuss one more problem on complex function which was asked in GTU Summer 2020 exam. So the question is about finding real and imaginary parts of a complex function but in terms of polar coordinates r and theta. We know that if we take z equal to x plus iy, we obtain f of z equal to uxy plus I times vxy. So here x and u and v are functions of x and y if we take z equal to x plus iy. But if we take polar form of complex number, polar form of z equal to x plus iy is r into cos theta plus I sin theta, then we will obtain our function in terms of r and theta. So in this question we have to write our function in terms of r and theta. So we will use polar coordinates and our function is z plus 1 by z. So we know that 1 by z is undefined at z equal to 0. So the domain of function f of z is set of all complex numbers minus 0. So our points in the domain are non-zero complex numbers. So we start by taking non-zero complex number. So we assume that z equal to r times cos theta plus I sin theta, and this z is non-zero, so we consider r greater than 0. R is absolute value of z and absolute value of z is positive if and only if z is non-zero. Now we substitute this value of z in f of z and we try to simplify in terms of this expression u plus iv. So then f of z is z plus 1 by z, z is r into cos theta plus I sin theta, and 1 by z is 1 over r into cos theta plus I sin theta. So this is equal to r into cos theta plus I sin theta, and this we can rewrite as 1 by r cos theta plus I sin theta to the power minus 1. So I am replacing 1 over cos theta plus I sin theta by cos theta plus I sin theta raised to minus 1. Now this I keep as it is, r into cos theta plus I sin theta, and here I apply de Moivre's formula. Okay, we know that de Moivre's formula is cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. So here we apply this formula by taking n equal to minus 1. So we have cosine of minus theta plus I sin of minus theta. We multiply this angle theta by power minus 1 and we write in the bracket that by applying de Moivre's formula, which is cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta. Now this we keep as it is for the time being, r into cos theta plus I sin theta plus 1 by r. Now we know that cos is even function, so cosine of minus theta is cos theta and sine is odd function, so sine of minus theta is minus sin theta. So this is minus I times sin theta. Now we collect those terms which are not multiplied with I and terms which are multiplied with I. So for that we multiply these two, r and cos theta plus I sin theta. So I multiply by r, I multiply this whole bracket by r. Similarly I multiply this bracket by 1 by r. So 1 by r cos theta minus I times 1 by r sin theta. Now we concentrate on those terms which are not multiplied by I. So these two terms are independent of I. So we combine those two terms, r cos theta plus 1 by r into cos theta, and we take these two terms simultaneously, which are multiplied with I. So I r sin theta minus I divided by r sin theta. Now from these two terms we can take cos theta common, so we have r plus 1 by r, and cos theta is outside this bracket, and here we can take I sin theta common, and we have r minus 1 by r sin theta into I. Okay, so I take I sin theta common, I into sin theta, and I have r minus 1 by r in the bracket. So now I can compare with u plus iv, u as a function of r theta, v as a function of r theta. Okay, so we can see that our function is in this form, with u equal to r plus 1 by r cos theta and v equal to r minus 1 by r sin theta. So we have written our function in this form: some function of r and theta, say u, which is r plus 1 by r cos theta, plus I into some function of r theta, which is r minus 1 by r into sin theta. And we are asked to express our function in this form: f of z equal to some function of r theta plus I into some function of r theta. So this is the expression of our function f of z in this form: u r theta plus I into v r theta. So we find this expression for f of z in terms of r and theta. Here r plus 1 by r cos theta is real part of f of z, and r minus 1 by r sin theta is imaginary part of f of z. So in this way you can write down f of z in terms of r and theta. You have to start by taking z equal to r into cos theta plus I sin theta, which is polar form of complex variable z, and simply substitute z in this right hand side of given function, and after simplifying we are able to express f of z in terms of u plus iv, where u and v are functions of r and theta. Okay, so this is very easy question. You can do it easily by simply considering z equal to r into cos theta plus I sin theta. So this is all about this session. I hope you like it. Thank you.